Hey guys, this is Joseph Sharp with Lead Tech Service. I just wanted to do another tutorial video on the audio IC for iPhone 7. We had this guy come in, boot looping, showed up with grayed out microphones, some issues in the audio. So where you would go to speakerphone, something like that, it would prevent it from putting somebody on speakerphone while they're in call. Other issues with this, voice memos wouldn't have showed up. Originally the customer wanted us to just replace the bottom flex because most of the service we do is for other shops. They said, hey, just replace the bottom flex, let's get it in and out. Replaced it, and now it's boot looping. So two things could have happened. This phone could have been bent while it's being worked on. That would have caused this audio IC to delaminate, or more than likely, where it was separating before, it's just become worse now. The grayed out microphones is step one, and then as soon as that pad tears a little bit more and then starts or restarts the phone, if it doesn't have those pads connected, it's going to start boot looping. That boot loop is the first go-to for the iPhone 7. If something is wrong, it does a self-test and it says, hey, are all my parts there? Is my front-facing camera there? Is my microphone there? Do I have the correct time? If any of these factors fail, the phone just starts to boot loop, and it'll do that over and over again. So what we did, we went ahead and took the board out of this phone. I have this mounted in a cheapo board holder. These are like $9 on Amazon. It works really well for me. If I need to steal a component or do something like that, I also have the shield out of an iPhone 6. This is the mid-frame shield out of a 6 Plus, and so I use that to reball chips and stuff on. I typically use a blue plate to work on, like a work surface, so I don't burn my desk here. I've had many desks that just have little black burn spots all over them. So what we have here is a iPhone 7. This board is the 00189A board. There's also a 00188 board, and that would have been a prior version to this one. The difference between the two is the layout in this area here. Everything else on the board seems pretty similar, but this area is quite different. Let's see, this chip here, this is an Intel chip. On the newer versions, which this is the newer version, they'll be using Intel chips. On the older version, you'll see a Qualcomm chip, and it'll actually say Qualcomm across the top. And those are the two main differences. This actually has an issue where it will stop feeding power to Qualcomm, and you'll get searching no service from that, and some other weird, usually a boot loop type issue. But in this case, he was complaining about microphones before the phone started boot looping, so we know that the audio IC is probably the case. And there are a few components down in this region here. Let me zoom out here so we can see. So there are a few components down underneath the shielding. You can see 1, 2, 3 there. And so what's happening is those are connected up underneath this, and as this phone flexes back and forth, those components are going to, there's little lines that go to it, and that chip is going to lift off, and it's going to take the pads with it, but leave the components where they're at, so you get a separation there. One function from those three is a timer, and so typically with audio, what it's going to do is produce a little signal that says, 1 millisecond, 1 millisecond, 1 millisecond, 1 millisecond. And if that's broken off and the phone can't get the correct timing from this chip, it doesn't know what to do. It just freaks out. The whole system is relying on this one little signal, And it goes straight from here through this component to the CPU, and there's no other test method for it. I could go through and remove this section of board, which I typically do if it's a not so cut and dry repair and I need to test some things. On this one, I'm under the assumption that this is the cause. It's the audio IC. Let me switch over to schematic so you can see what I'm talking about. So I have Adobe Acrobat Pro open. This is the Viet Mobile iPhone 7 full schematic. And so what we can see is the schematic, if you look at the board layout first and foremost, it's actually different. This is our Qualcomm board layout, not the Intel one we have. So this isn't going to be identical, but most of the layout is going to be the same. The continuity for all your FPCs are going to be the same. Where things are connecting is pretty similar. It's not going to be identical anymore, but it's going to be pretty close. So we can look at the back of the board. This side is what we actually have on the table. It's thundering outside. My power might go out. That'll be fun. I can close for the day. So let's zoom in here. So this is U3101. This is our audio IC. And we can see at this bottom right corner, I don't pan all the way out. There we go. So we can see at this bottom right corner, U3101, we have R3201, so it's a resistor, 1103, and 3202. And those are all resistors here in this bottom corner. Usually resistors are in line, and we can take a look at that. We'll just copy this. I will search for that guy further down in the schematic, and we'll see, you know, where he's at. And that is really zoomed in. So that connects a 1v8 SD RAM line, this guy, to an SBA AP to codec line. And so right to U3101. And we can see that this is system 3 of 3. This guy, where it says critical, that needs to be underlined 2 or 3 times. This chip causes more problems than anything I've ever seen on any phone. With Touch IC disease, you get 1 symptom, maybe 2, where you got a flickering gray bar and no touch. This guy causes all kinds of problems, from microphones to boot loops. In this case, the boot loop on this phone, the phone will flash an Apple logo and it'll sit there on the Apple logo for like 5 minutes. And if you plug it into a computer, it'll say, hey, enter the passcode on this phone, like it's actually running. So that's typically the issue we're going to see from this chip. Are strange things. And I don't want to say it's a go-to because this is not the easiest repair. But if there were an easier way to test it than removing it, reballing it, and putting it back on, that's probably what I would tend to do. For me, the soldering part is going to be a little bit easier than going through and tracking down the problem. I can, and I'm pretty good at tracking down the issue, but when there's something so well known like this, that, hey, these are my symptoms, let me just do the surgery on it. We can, you know, test everything and make sure everything's right and worry about messing up this shielding here, which really isn't a big deal at the end of the day. But what I would prefer to do is just to swap this guy out, make sure that those pads are connected, because it's usually our issue, and usually run some jumpers here, and then put this guy back in place. Those pads, we'll see when the chip comes off, there's going to be 1 or 2 possibly 4 pads that have already torn off of the board underneath. And it's going to be so common that as we go into the future, these are going to be like the touch IC disease, where we're just going to see this chip over and over and over again. This is what we're seeing underneath. So this is a iPhone 7 board. This is potentially, yeah, it is an iPhone 7 board. This is the same layout, so it's a 189. And if I put this under the microscope, I'm going to lay it on top there. I've already removed the shielding there. Let me zoom in. I'm going to zoom way in. I don't really do this because I like to see everything that's going on. And so if we zoom way in, what we can see are, let me clean this, it has some flux from the last time I worked on it. And to clean, this is alcohol. I think Rite Aid Up and Up brand, so Target alcohol. And a toothbrush. I typically use a toothbrush for a month or two, and then we'll switch over and use it for soldering and throw my old soldering toothbrush away. I'm just going to scrub that with some alcohol. And what we can see is that evaporates very slowly because it's low-grade alcohol. Is that under there we have a couple components. So what we have is this chip here goes to this number 3, and there's a little trace that's on there and you can barely see it, and there's another one right there, and there's another one from there to there, and there's a few others like there and there that are, these are tiny little pieces of metal sitting on top of fiberglass, and they're barely hanging on there. And so when we go and we remove these solder balls, underneath there is a little pad, and the pad is again just a piece of copper sitting on top of fiberglass, and there's nothing to hold that on except for the glue from where the fiberglass was constructed. So what I'd like to do is remove this chip, clean it, and put it back on, and get it out. Typically, I can make this a 30-minute repair. It's going to take me about 10 minutes to get the board out, about 10 minutes to get the new board in, and 20 minutes for the repair inside. And my music's freaking me out, so we're going to fast forward on that. Today I have royalty-free music paradise on YouTube. I had some issues in earlier posts finding quality music, and that's been a big sticking point for me. There we go. It's a little bit nicer. So what I'd like to do is jump over to ZXW tools. This is what's on the left hand of my screen. It's going to be, I believe, right there. So this is Adobe. This is ZXW. Adobe is just a PDF file with all the board layouts. And so with ZXW, this has all of our schematics. And with these schematics, usually these things are named and labeled, and you can click on one component, it'll show you another component. Whereas the Adobe is a little more mental, where you have to look at it and deduce yourself where and why things are the way they are. So I'm going to open up the 1088A version of the schematic. This is the Qualcomm version and not the Intel version that we're working on here. So let me full screen this and zoom in, and you can see when I click on something, other things get highlighted. So on here I've clicked on U1701. It's a 3-volt NAND rail. and we can click around and see that, hey, these look like ground pads, and all this is ground. So let me zoom in here, and you can see actually how many solder points are under this thing. And so C12, this is the big one. This is usually the one that's removed. This is the worst issue that we see on this phone, is what's highlighted in red here. This C12, which is row A, row B, row C, and then like 7, 9, 12. Starting with pin A1 and then going all the way down to M12. This is the last component. You know, with the iPhone 6 Plus touch disease, usually the pads that pull are around M1, which is in the bottom left corner. So on this one, similar layout. A1's going to be up here, but in this case it's going to be the other side. So what's happening is these boards flex. When you're using the phone, you have the back housing here, and so this guy is going to tend to bend and warp, and these are more solid frames than the 6 Plus, but because they're more solid frame, Apple tended to put more more faith in this housing, and was like, hey, we have a more solid frame, let's go ahead and skimp on the board some more. So what we have is, you can see that there's very little metal there in the middle of this board, and so when this is going to bend and flex, you can see this board is actually completely bent. Now this isn't a board that I'm working on. Usually I steal parts from this board, but we can see right where that fault line is right where that chip sets. And so how I usually explain to my customers and to other shops is, you have a chip, and it's a glass chip sitting on top of marbles, and then that marbles is sitting on a fiberglass substrate, which is going to tend to warp, and that glass chip is going to sit completely straight. So what happens is, as this warps, it's going to separate, and those balls of solder under there are going to break apart. Now they can break apart, and like with the 6 or the 6 Plus, where you have touch disease, you can bend it and put that back in place. But what happens is, over time, those are going to be contacting like that, and oxygen is going to get in there, and it's going to corrode that metal, and it's going to remove the surface finish until it's too pitted, too porous to touch each other. And that's typically what we see with long-term touch disease of, hey, I was able to bend it, I was able to get some data off of it, I was able to do this and that, and now I can't do anything. Now the touch is completely gone. And this is the issue with these phones, is now that they're getting a little bit older, where it was, hey, my microphone disappeared, hey, this speakerphone isn't working, voice memos won't show up once in a while. Those problems are going to progress and progress until the phone is boot looping, because it's not getting signal from these lines. And it's failing that self-test on boot. And that's going to be a major problem in the future. I've lowered the price of this repair. Usually boot loop repairs are pretty expensive because there's so much stuff to go through and test. But on the 7 and 7 Plus, I've actually lowered that price quite a bit to match the 6 Plus pricing with my touch IC disease. Just because it's so prevalent, we see it every single day, and it's not typically something new. It's the same old in and out. We know the process, and I know exactly what to do when I see this issue of, hey, you don't have microphones, hey, it's boot looping, go ahead and swap this chip out. And that's probably the issue. There are other troubleshooting steps that I've already taken because they were complaining about their in-call microphone or speakerphone microphone what we did was, per customer request, was go ahead and replace this bottom charging port assembly. These charging ports are pretty simple. It's screwed into the board in a few places, or into the back housing in a few places, and then you have two microphones here at the bottom, which are for your in-call, so when you're talking to somebody on the phone, and then it folds over at the top and plugs into the board. So I've already gone through and I've checked to see that, hey, all this stuff looks okay. This connector's not damaged. The bottom ports aren't full. That's not the case. And the fact is that this guy's boot looping, or intermittently booting, to a state where we can actually use it. I've only seen once so far since he brought it in that what was happening with it is that with this phone, where it was only coming in with microphones, the only time I saw it was once when it came up after booting up for about 5 minutes. And it showed up for a minute and said, hey, enter your passcode, and the home button and different things weren't working, and then just went back into a boot loop. And that's not typically what we want to see. So what I'm going to do is I'm going to add a little bit of flux here. Now flux is the secret sauce to soldering. If you do any kind of welding or brazing, you know that you have to keep molten metal under flux or under some kind of ambient or some kind of noble gas to keep this thing, keep the molten metal from touching oxygen. If I were to be like forming titanium or something like that, where you're trying to pour molten titanium into a form, you actually have to do it under a vacuum, so that you don't get pitted metal and make it weak. So that's what we do with flux here, is this is going to keep oxygen from hitting this molten metal and getting in there to make it more porous and unusable. So I'm just going to turn my heat gun up. I have it at 350 degrees Celsius with a 50% airflow. What I use is a AOYUE. It's a 738H repair system. So this has not only your hot air gun, but one port for either a soldering iron or hot tweezers, and then it has a vacuum pump in it as well, so it'll suck some smoke from the area. I also have an air extractor here. This is a air extractor that I put together. It has a 240 mil fan in it. That 240 mil fan is pulling smoke from my desk, and it's pulling it through a carbon filter and through a HEPA filter, and that's going to remove contaminants from my workspace. Even though I work in this environment every day, I don't like breathing solder smoke. I don't like the smell of solder smoke. I don't like it in my eyes. I don't like it anywhere near me. It is a toxin, and I want to live forever, and breathing solder smoke all day is kind of counterproductive. So what I'm going to do here is, with 350 degrees Celsius and some tweezers, these are cheapo tweezers that I've filed down under the microscope. I've engraved soldering on them so nobody steals them and everybody knows whose desk they belong on. I keep these with the cap on them whenever I'm not using them, and I luckily have not dropped them yet. I've been using the same tweezers for about 2 years, and they've really worked well for me. I have a nicer pair of tweezers a pair of Vetus tweezers that I'll use for really, really small stuff that I might have to break out later if we have some trace work to do. So on here, I'm gonna add a little bit of heat. I'm just gonna warm up this whole area. What I'm waiting for is to see boiling. You can see it's boiling now, and we have flux coming out from underneath the chip. Now once it starts boiling, I'm going to take the heat off, and that's going to suck all that flux up underneath this. There are quite a bit of grounding pads under here, so we just want to be careful with that. Straight up, I nudged 1 or 2 components. So with that, I'll use an X-Acto knife. I don't use a scalpel. X-Acto knives are a little bit cheaper and readily available, so if I break one or if I need to set up another workstation for a new tech, it'll be pretty simple for me to reuse these components or to find some new ones that are identical to what I'm working with, and to limit those factors that could cause confusion of, hey, which tool do I use? Yours is different than mine. Yours doesn't get hot and mine does. You know, simple issues like that. Okay. I'm just gonna nudge these guys back in place. It doesn't take much. They want to be they want to be at their home. They want to sit flush on that pad. Zoom in, back in there. What I'm using for my main camera is it's a pen microscope. And the webcam I'm using is like a 10 or 20-year-old Microsoft 720p webcam. Probably not ideal for live streaming, but we're gonna make it work. I'm just getting into the live streaming stuff, and I tend to like it. I want to show other people what I do, and so they can get into it. I think our whole industry is moving to a point where we can start doing microsoldering repairs at a shop level instead of having microsoldering centers. It'll take a lot of learning and training, and a lot of steady hands, because this isn't exactly the same as a shop where you can just turn a screwdriver and you can take this off, you can take this off. A lot of people are afraid to start soldering. They're afraid to, you know, get into this industry and, you know, to mess something up or to damage a board. There are ways microsoldering to damage a board beyond a point where it can be repaired. You could break NAND, or you could damage the CPU. Sometimes after this repair you'll have searching no service, or no microphones, or other kinds of weird issues. And, you know, typically when you swap out a screen, the worst that's going to happen is your proximity sensor won't work and you have to swap that out, and it takes you another 10 minutes. If I put too much heat on this board and I pop the CPU, it could take me days to put that back in place. To reball and to remove that old CPU and to put the new one on. And I have other things in queue that could be knocked out pretty quickly. So this is a brand new soldering tip, and it is not liking my solder. So You guys are watching the process of me trying to tin a brand new soldering iron. I'm just gonna add some flux to it. I'm adding flux directly to the end of the soldering iron. I'm using a brass sponge, and then I'll try to add some solder again, and I'll go back and forth through this process until the solder starts to stick to the end of this iron. This is something that has to be done when you get a new solder tip on this one. My old solder tip was starting to crack and break apart, and while that's not typically an issue, it is if you are using inexpensive solder tips. I can order 10 solder tips for something like $6, and the fact is that you're going to go through them. You're heating up a piece of metal for an extended period of time. It will degrade. Metal likes to be at room temperature usually, and so when you have it at 400 or 500 degrees, you know, all day every day doing this kind of work, you know, it's going to tend to kind of break down on you. Again, oxygen is going to get in there into the hot metal, and it's going to cause things to go awry. It's going to break up that crystalline structure of the metal. So again, I'm just running this over the brass rod. I'm trying to get that to stick. With soldering on there, with soldering, or micro soldering I should say, what we're looking to do is to load our soldering irons. There we go. What we want to do is load our soldering iron. So now, starting to get it to the point where that's going to stick to it. This is a little bit smaller iron than I like to use. But it's what I had, and so it's what we're gonna make do with. So again, I'm just adding a little bit of solder to that, and then cleaning it. I can do this under the microscope so it's easier to see. So we have a little bead of solder on there. If you get that, you want to take your fingers and pinch it off. Your soldering iron won't actually stick to that. This is rosin core solder, 6040 from Radio Shack. I know. Back in the day, I went through and I bought a lot of their solder when they were going out of business. They had a few stores here in Wilmington, and I just went through and I tried to buy up as much stuff as I could before they went out. They were a really good company. They helped me get into soldering and micro soldering and electronics, and they really influenced me. And you can see now that it's starting to stick to my soldering iron. That's actually what I was looking for. We want that to glob up on there, and to sit there while you're micro soldering. One thing that you may not be aware of is that you want to put your soldering iron back with it loaded like this. That's going to keep it a little bit nicer and ready to use the next time. If you clean that soldering iron really well and then put it back, oxygen is going to get to the iron itself and start to degrade that. Let me get back focused in here. And so we see these aren't all even. We have one or two big globs of solder here and here and here. Here's one. And we just want to take those back. I'm going to take them down so they're more or less flat. So again, before we have any molten metal, it needs to be under flux. Some flux there. And this is one reason I don't like using a tiny soldering iron, because it's having a lot of trouble heating up all this mass. I do not like that at all. That is a lot of trouble. And so what's happening here is my board has more mass than my soldering iron does, and it's trying to pull the solder away from my iron, where typically my iron's going to be pulling solder from my board. What we're going to do is I'm going to do this the Chinese way and not the American way. What I have is Goot wick, 3mm. This is solder wick. And so what I'm going to do is tear off a chunk of this. I'm going to put it in my tweezers like that. I'm going to lower my air to about 280. And I'm going to come back in here with this air. And I'm going to direct it onto this little piece of solder wick. The reason I broke the solder wick down so it doesn't take up as much space. We want to lower the thermal mass of whatever we're heating up as much as possible. That's one reason when you're working on these boards is that even if you are talented enough to do it inside the phone, inside the back housing, or to work on it there, you really don't want to do that. You want to limit your thermal mass as much as possible. That's one reason I prefer not to have I'm going to turn my board 90 degrees. Some more. I'm always amazed at how much solder wick can actually pick up. That looks good. There's my very nasty piece of solder wick. Set that aside. So now I do want to test the connection between here and here. These are those components I was showing. I want to test between right here, number 3, and that second resistor there. So I'm going to do that. I'm going to wait for this board to cool down a little bit. And clean the area again. Burnt flux can impede your test equipment. So whatever you're using to test out, whether it's multimeter or an oscilloscope, anything like that, you want to remove all that flux before you do anything. So I'm using a Southwire 130S multimeter. The most important part is that it has continuity mode. That's the one that looks like a sideways Wi-Fi. And that's going to beep at us when we know that there's a connection. So if we actually take the 2 leads, right now it says OL for out of limits, and we tap them together, it gives an audible beep, and it shows a 0 because there's no resistance between this end and that one. So we can do the same thing on our board, where if this connects the 2, then we know that that pad is okay. So we go in here, and I do get an audible beep. No beep there. No beep there. That beep's okay. 2 more down here. And those beep okay. Now these are all fine, quote unquote. Whether or not we want to add a little wire and go ahead and do some preventative maintenance on here is probably not a bad idea, and something that I'm going to do anyways, just add some longevity to this device. Whether we need all 4 there is kind of a matter of preference. This housing isn't terribly bent, so I don't think there was too much stress to damage this board. I noticed my music stopped, so I'm gonna add a little bit back there in the background. So, that's our board. This is the chip we just removed. I have new audio ICs. This audio IC could be damaged. Sometimes I see these start to overheat and start to fail out just on their own. So what I've started doing is to make sure we replace these outright. They're not serial tied to the board, so it's really no big deal to take one off and to put another one on. I may have spoken too soon. I'm going through my binder here. This has all my parts in it. With a lot of controllers and power modules. There we go. This audio IC, if you do want to pull it off another board, is also the same in the 6S, 6S Plus, 7, and 7 Plus. In case you don't have any newer boards to take a power module off of. This is a mobile-centric part. They're calling this the Big Audio IC. Super technical there at mobile-centric. But Big Audio IC, that's apparently what we're working on today. I like to call it U3101, as like the schematic does. They're also going to call it CS42L71, in case you needed to look up schematics for it, or WLC-SP1. So let me go in here and show how much work this guy does. I'm going to search for U3101 again. Here is system 2 of 3. That's where it's located on the board. This is system 1 of 3. These are, it's actually called the Caltra. So you know our Touch IC disease is due to a chip called Mason. This one is called Caltra. So I might start using that instead to describe this sucker. So this is system 1 of 3. That's a pretty decent size there. This is system Caltra audio codec, power and I/O. And this is 2 of 3. And over here is 3 of 3. And we can see how many inputs and outputs this guy has, and how many things just could go wrong in these 2 or 3 pages of schematics that are dedicated to this chip. So also let me go through here and show that these align. Now the one in question, according to ZXW, is C12. And we can go through, and this is 1 of 1. No C12 on that one. I'm not overlooking it. Power and audio. And G12, E12. And C12. And same thing as ZXW says, is it's I2S AP to codec MCLK, so something M-clock. We can see here that pin is called M-clock. So I'm going to do is copy this, and we're going to go to that place. And this is straight to U0700, which is our CPU. This is our system on chip. That's our CPU. And so we can see that R1103 is the only thing standing in the way of this straight to our CPU. We can always see that on ZXW by clicking on 1103. Zoom out. It's nowhere on the side of the board. If I hit tab to switch to the other side, we can see that there's one little pin here. Again, BV65, which is where it showed up on the CPU on our schematic too. And that's where it lands on here. Hit tab to get back. And back in here. And that's actually what we're working on. What you can also do is search our schematic for R1103. It's going to find it, of course, in the schematic. It's going to find it right there again. I'm going to line this properly again under the microscope. Zoom back out. See you again. There we go. I'll remember not to waste a new IC by having to take it off again. Go ahead and clean this up. Swap that out. So the way I'm going to clean this is by removing the top there. This blade is about had it. Throw that out. I'm gonna drop my new blade on the floor. So this is a Revel blade dispenser from Michael's or any hobby or arts and crafts store. These work just fine. I see medical scalpels and things for sale online. I feel that medical scalpels are meant to cut through flesh. But hardened stainless steel, like these blades are made of, are good for cutting through aluminum, and things like this plating here, because you can use the back of these to just kind of wedge your way through it, to scrape it off one little part at a time. Need a little more light to work on stuff like this. Okay. Check your view and make sure it's not blown out. That's okay. What I'm doing is I'm just scraping the covering of that trace off. Just uncovering the copper. of the circuit board. And you can see that copper is starting to show through. It doesn't take a lot to do that. You barely... All I'm doing is just dragging the scalpel across it, and not even applying any pressure or weight. And you do that a few times, and that covering's coming off. You don't want to cut down into it. If you actually cut that line, it's going to cause some issue. And then again, this is a mechanic wire. This is 0.02 millimeter mechanic wire. I've shown this a few times on video, and this is what I like to work with. I also have speaker wire. If I'm doing something a little bit heavier, I'll use speaker wire instead. It's a bit too thick to work with these kinds of boards, but if you have a larger PCB with some kind of issue on it, say a USB port broken off on a laptop, then and you need to run a trace, that's what I would prefer to use. It's a little bit heavier, and it's okay for a little bit higher current to go through it. I really wouldn't want to see 2 amps go through something this thin. It'd probably get red hot and just melt. So I'm gonna cut about 1 inch off. I used to unreel 2-3 inches at a time of this stuff, but you really only need about 1 inch. I'm gonna switch to my Vetus tweezers. These are a little more precise. They are way sharper than the soldering tweezers I manufactured. So we're gonna set those aside. I'm gonna take this, put it kind of where it needs to be. Really yellow flux. I assume I overheated it when I was trying to manufacture, or trying to make my new soldering tip. Get that nasty stuff out of the way. There we go. Put that in the way. So I can show you what this looks like next to a hair. We have that line there. This is a hair, and you can see that it's not. It's actually closer to the thickness of that other wire I had. The soldering wire is a lot thinner than that is. It's kind of translucent, so you may not be able to see it properly, but it is a lot thinner. So what I'm going to do is kind of take, I'm going to set that in place. So what I like to do is tack this to a solder point in the general vicinity. And once it's tacked, it'll kind of stay in place. I'm just going to hold it, the tweezers. Load that soldering iron a little bit. And so, if you're shaky, I'm starting to get follow your tweezers to whatever they're holding. Just set it right on top of there. Well, that should be pretty well tacked in place on whatever that component is. When you apply that much heat in a small space, it's going to tend to caramelize your flux, for lack of a better term. So you don't want it to be this sticky. It'll get in between your work pieces there, and prevent it from binding. You can see the soldering point. Not the greatest idea because it was a non-contact pin. Cut that off and try it again. Non-contact pins don't actually do anything. They kind of sit on the board and it makes it easier to manufacture. If there's just an array of pins there. So let's try one right above it. I would be interested to see who actually turns out to watch this kind of stuff. I watch it for work if I'm trying to learn to do something new. I look for these videos a lot for issues that somebody's already tracked down. Microsoldering issues can take you hours or even days to track down an answer for a problem you're having. And these videos were super helpful to me when I was getting started out. Like Jessa and Rosman would post kind of quick tutorials of, hey, we have this this issue where you're going to see this a lot. You know, instead of spending hours to test, you know, and to find out the issue with what's going on with it, check this, that, and the other. If these are the cases and these are the same symptoms you're getting, it's probably this issue, and you can go ahead and replace this thing. But they kind of ran you through, they helped narrow it down. Unfortunately, with this kind of repair, because it goes straight to the CPU, we can't test, you know, voltage. We can't test whether or not something's working properly. One thing you would have been able to see is that this chip will sometimes overheat if it's failing. And heat is a great indicator of something gone terribly awry. What I've done is I've tacked this wire in place. A little tiny piece of wire on that board now. Hard for me to see it. So what I'm going to do is I'm going to come over here and we're going to grab the neck of this wire. Just like that. And some more flux. Kind of maneuvering that wire in place. You don't want to short anything else out, and that's one thing that we'll test when we're done to make sure that we didn't short anything to the nearest neighbors. The nearest neighbors would be B12 and D12 on that row we're working on. Polyester fiber. There we go. What I was waiting for was for that component to be what we call wetted. W-E-T-T-E-D. Wetted is the term that you're going to use to have a piece of wire where it's going to soak up the piece of wire into form kind of filleted edges around it. I'm going to clean this a little bit. Zoom in here. Now you might be able to see that it's actually wetted there. So these are our solder points. This is the pad that's usually missing. This is the resistor that we just soldered a little wire to. You can see that that wire goes from here to here, and there's solder encasing all of it. It's taken up that solder. There's a point here that's like kind of soldered, and this one too. These components are kind of soldered to this wire. This one is wetted. This one isn't. You can see that I get a little bit of movement out of it. You probably have electrical continuity there. But over time with use, that's going to kind of break off. And we only want to solder C12, which is that topmost third row to that resistor near it. And we just want to make the little jumper where the red is in the top left of your screen and nothing else. So what I'm going to do is through my webcam, which is super difficult, come in here and I'm just going to cut this off a little bit. We're just going to fold that away. Zoomed in so much I have no vision through my microscope. Doing this on a monitor is not conducive to a working environment. This is a lot harder than it looked. My hand-eye coordination is all 100% based on being able to work through this microscope. Okay, I can't do that. I like you, YouTube, but I'm not going to mess up a customer's motherboard for you. So that's what it looked like through my microscope a second ago. Okay. The view that you just had is typically what I'm going to see through the microscope. For me, all that's in my field of view is what I'm working on. It's just like real life, that anything that doesn't pertain to me or isn't relevant, something that I don't need, I'm just going to kind of push it to the side, get it out of my field of view. I don't need it. Now that we have that done, I think it looks okay on this. There's no real debris. So this flux is pretty new. I'm gonna start to load this guy with flux. More flux, enough to float this component in on. Take my new audio IC, and we're going to keep in mind that the way ZXW and these other tools have this board situated is like that. When it's like that, A1 is in the top left corner. A1 is also going to have the arrow on it. We want to align that with each other. So we're just going to set this right here. Again, you have little domes on the bottom of this. That'll look kind of the mirror opposite of your board. That's what the bottom of this guy looks like. If you zoom way in on it, it's kind of pretty. This is where most of the action happens for the logic. Everything above that copper is going to be mostly heatsink and substrate. sometimes I'll see technicians just crack this top casing a little bit, and then throw the whole chip out because they cracked that top casing a little bit. When in actuality, it's only that substrate underneath that really matters. And even if you did something to damage the substrate, you can still run jumpers, just like you can on a PCB, just on a smaller scale than we're used to working on. That's more or less where I need her to be. And these will self-align, just like the capacitor when I first started. When you heat it up, it's going to jump back into where it wants to be, as long as you don't blow it completely off the board with too much air pressure. Again, this hot air gun is set to 350. I'm going to lower that pressure down to 30%. And kind of warm this guy up slowly. Boil that flux out from under it. Maybe tack it in place with the hot air, and then going for the kill, which is going to have me kind of blow so much air on this thing that the whole thing floats, and then we can poke it, and it should be where it wants to be without much more action. So. There we go. Don't move. Let's see. Now she's happy. I just want to take it slow. I don't like putting heat on boards for that long. As long as you have it controlled, it's okay. I don't see any solder balls anywhere else on the board. There's a lot of dried up flux here now. Seems pretty solid. Look at it from the side. Well, how about that side? You see that it's flat, and before it was angled up a little bit. That's nice and flat now. You can see our little jumper still in place. It always amazes me that those don't go anywhere when we put heat on these boards, that they just stay where they're at. One thing I would recommend before reassembling these is to run it through an ultrasonic scrubber. That's going to remove any flux from the board. This flux, if you leave it on the board for too long, which is what I typically see from other shops who microsolder, is that they'll leave flux on the board and it'll eat into different stuff. And you don't want to use a board that has a lot of flux left over on it. So right now I'm just scrubbing it to get any larger particles off, and then we'll run it through the ultrasonic before final reassembly. We've done that. Going to take it off of the stand. Lightly reassemble it into the back housing. All I'm doing is I'm setting the motherboard back into the phone. For people new to this type of repair, where you have to pull the full assembly out, this top assembly doesn't have to come all the way out. Leave the screw in, take the other three out. You can actually flip this over and then remove that one screw, leave that one in place, and you can just pick up the motherboard underneath it and slide it out. That's by far the easiest way to do that. And you have 2 or 3 less things to put back together. That's why when I was saying from the get-go that it takes me about 10 minutes to disassemble an entire phone, people kind of scoff. But I'm from the generation that had to disassemble and reassemble entire iPhone 4s just to replace the screen on those. So seeing iPhone 7s and things that are so easy to repair kind of makes me hopeful for the for Apple moving forward. as they're making it easier and easier for us to actually fix these things, whether they want to say it or not. I think they love love things that are repairable. This must be a long stream. I've run through 2 entire audio recordings. I'm just snapping that stuff in place. I fold over our flex cable. It's not very well aligned. I think that's one thing my tech was complaining about after he put that first flex cable in, that he's like, hey, it won't pop down. I'm gonna do flex that a bit. To get that in place. Just peeled that up a little bit. That flex cable, I want to get down to the point where I can do this. You can really see how these boards can get broken by being flexed. So now that I have that there, one thing I'd recommend for newer techs is to spend $200 or $300 on the AppleCare training. Even if you don't take the AppleCare certification exam, which is I think $150 per test. But to go ahead and do the training, it's going to show you how to properly disassemble and reassemble all iPhones, all MacBooks, basically anything that Apple produces, besides iPods and iPads, because those aren't meant to be worked on. Any of their equipment that's meant to be worked on, it's going to show you how to properly repair those things. It'll show you how to remove Wi-Fi antennas and things like that, and how to put those on. A lot of people have frustration with these. That training guide says exactly how to do that, and that's to align it by holding it by the neck here, and then use the pointed end of the black stick to pop it in place. And you will never have any issue laying that kind of stuff down again. I did have to remove this from the top corner. Got caught underneath the board when I was messing with that flex. Put that guy back up there. Put this out here. Okay, and from here on out, it's a normal screen repair. These are little Lego connectors. They just pop in place. Okay. We've done that. We can see if this phone is going to boot. I have an Apple logo. And another Apple logo. So this one is still boot looping. I'm going to remove the battery. I'm going to undo the top flex assembly. Get it down to just a bare motherboard. So it's just a power button. I'll undo that flex cable, which is a little too tight. I'll rule some other stuff out. Put the battery back on. Okay. And we still have a boot loop situation. So in this case, some more testing could be needed. This is pretty common with this industry that it's going to present as one thing and do something completely different. It could be a failing component. I can go through and check for heat on the board, and we'll do that. It could be a failed power supply, something that's just not producing voltage. The solder points under what I just repaired could be bad. Anything like that could cause this issue. I'm going to try to plug it into my computer and see if it has any draw. Of course it won't because I unplugged the that flex cable. I'm going to put a donor flex cable in there for the time being. It's just a normal boot loop at this point. As it's pulling 0.06, 0.08, and then loop. 0.06, 0.08, and then loop. It never actually registers on my computer now. So, could be a combination of problems that the audio IC has issues and the power module IC has issues that's not firing that guy off. So let's take this back apart. There are things that can cause that, like a battery being below nominal voltage. That can cause that same sort of issue with it just boot looping. So let me grab a known good battery, and we'll try that and see if that causes. Alright, so I'm going to try this with 100% known good components. I'm also going to restart my jams. Alright, so I have this known good charging port, known good battery, and also a brand new screen as well, with no home button or anything like that installed. We're just going to narrow down, exactly what's going on with this guy. Don't like there to be a myriad of issues. I like there to be one issue in and out, but not always what we get. We have an app logo. And Hulu. So, same exact issue. 0.08, nothing. 0.09, nothing. 0.43, back down to 0.08, and nothing. See if it's even recognizing the battery. Just gonna plug this in. Those two. And so with no battery plugged in, we're just getting 0.06, nothing, 0.06, nothing. So it's a different boot loop with no battery installed. This is one of the reasons that people get into this. And they're like, oh, I can do microsoldering, I can solder. But the soldering is the easy part. Soldering is like the grand finale for repairs. Soldering is very little of what I actually do. Most of it is troubleshooting, tracking down issues and saying, hey, is this an issue? Is this an issue? So now I'm going to switch over here to kind of troubleshooting mode, figuring out why it's behaving the way it is. I'm going to remove the water seal gasket, the dust seal gasket. I do this by adding a little bit of alcohol. And then your tweezers should get right under it. And it'll pull nearly 100% of those up and off the board. Once those dry, you can actually reapply them like they were brand new. So what I'm doing is looking at all these components along here, see if there's any kind of issue. These look okay. Check the battery connector. This is an old iPhone 4 problem of where it's worked on, somebody unplugs the battery connector and they're just like a tad too forceful with it, and they'll break that battery connector off the board. We can come down here to the AC connector, kind of inspect. Nothing here really looks out of whack. It could be a broken joint, which I can multimeter and see if they are in fact broken, if they have continuity. Sometimes these guys will get broken off. Look under here again. It's where we were a minute ago. I'm still in continuity mode, so this beeps when I find a short. Neither one of those have a path to ground. That one does. So it's a little too hard to get under there to test those out. So. I'm going to switch back to the 00189, which is this board. Just going to zoom in here. You can see this one isn't labeled like the other one was. You can still see continuity of what's supposed to touch what. Look around here. It's our TriStar chip. Can be an issue. Everything visually looks okay. That guy's had a little trouble. Okay. So, no real shorts on the board. Plug a battery into this. I'm gonna plug my dock connector into it. And then we'll see. Check for hotspots and stuff like that. reorient this properly. I'm gonna go ahead and test for voltage. I'm gonna set my multimeter to 20 volts. Now I'm checking not for a beep, but for power. We have 3 volts there. No voltage there. Of 5 volt. .8. No volt. I'd like to know what exactly you are. These aren't labeled or anything. This is the 8 board. Sorry, the 00189 board. The newer of the two, and it doesn't have complete testing on it. That's where that connects to. We flip over to the other 7. Let's see if that's kind of a similar layout there. Because this one is, in fact, labeled. Okay. That is a similar... So that is... a accessory... PP... ACCVAR, so it's an accessory line. Just trying to trace through some of these issues. Trying to figure out if we have VCC main running, if we have any hotspots. .8 on that. There's nothing on that capacitor. .2 on that guy. .3, so we have VCC main. .3 there now. I'm not totally sure what that guy does. I'd like to look at the schematic again. that is connected to that. There's a resistor. And my guess here somewhere, it's probably cell signal. And that's going to fluctuate. Nothing down here is hot. Star's okay. The NAND isn't hot. Nothing else on here is terribly wrong. Just checking for macro issues like overheating or a full short to ground on one of the lines. Anything like that. I'm not saying that's the case. So what I'm going to do is I'm going to keep looking at this issue. I'm sorry that I had a false positive on here, but this is how we learn. Should have tested beforehand to make sure that there was voltage coming out of that clock line, and see if we had any kind of signal on there. Once that's done, then you want to repair components and not just swap out components. That is a sign of a not so great tech. Just replacing components without actually testing to see if they're bad. What I'm going to do is take a look at this again, maybe replace that power module, go through a couple forums and see where everybody else is out on a problem like this. I have a few other iPhone 7 boards that I'm going to test as well, and then I'm going to check continuity on some other stuff. But at that time, I'll sign off. Keep going on this problem, and I'll let you guys know what happens. Thanks.